Now the reason I wanted to mention that is that we want to, in talking about ug99, we need to talk about one of these stem rust genes that's been really, really important. It's a gene called SR31. And again, Gordon mentioned this yesterday. So way back in the 1930s, the short arm of Y chromosome 1, this is 1RS, was introgressed into wheat, and it replaced the 1BS arm of wheat. So, and you can see that here. So this is chromosome 1B, and this is the short arm, right? 1BL, 1RS. I've got that run the wrong way. Sorry, that should be 1BL, not S. So what's happened is, when they've cross-pollinated rye with wheat, that rye chromosome arm has actually replaced the wheat chromosome arm. And this is a differential stain here. So you can see the rye chromosome arm is shown in green. Of course, there are two of them because it's diploid. So this is rye chromosome arm 1R, and it's replaced wheat chromosome 1BS. So what was the significance of that? Well, that rye chromosome arm that was introgressed into hexaploid wheat carried some really, really good traits. 3 genes for rust resistance: SR31, YR9, LR26, right? So straight away there were 3 rust resistance genes that were brought into wheat from rye. It also, and we don't fully understand this, but it also conferred broad adaptation. So wheats that carry this rye chromosome arm seem to do better across a range of environments, yield better. So it was picked up by a lot of breeders, and it was used all around the world. A lot of European winter wheats, you name it. It was used very, very heavily because it conferred this yield advantage, but probably equally importantly, it had a stem rust resistance gene, SR31, and SR31 was effective for many, many years. There were no pathotypes of stem rust that could overcome that resistance gene. Until 1999 in Uganda. And this is where Zach comes into the picture. So there was some observations made in a nursery. Gordon mentioned this yesterday. Lines that they knew carried SR31 in a nursery in Uganda that had alarmingly high levels of stem rust in them, which was suggesting that a new race, a new pathotype of stem rust had emerged with virulence for that very important stem rust gene SR31. The sample was sent to Zach. He confirmed that that was indeed the case. So this was the first confirmed example of a stem rust pathotype with the ability to overcome SR31, despite the fact that the gene had been used around the world for so long in so many different wheat varieties. And the other thing about this ug99, as it was called initially, this isolate of stem rust that could overcome SR31, was that it was virulent on a lot of other important stem rust resistance genes as well. But the most important thing was its virulence on SR31. At the time when it was first found, there were some tests done in Uganda, and I should also say that that photograph there and that photograph there were taken by Professor Pretorius. He's not only good at identifying new pathotypes, he's also a very, very good photographer. When this new pathotype was confirmed, there were tests done in Africa, and that showed that something like 90 to 95% of the wheat varieties grown on 75 million hectares were rendered susceptible. This equated to something like 30% of the world's wheat acreage was rendered susceptible to stem rust by the occurrence of ug99. So we knew pretty early on this was a nasty pathogen. It was really, really worrying.